Hello everyone, welcome to another video from Advanced Math Tutors. Today, in our series on Calculus 2, I wanted to bring you some examples of integration by parts questions. Integration by parts, if we remember, here let me just write up the formula that we derived in the last video. The integral of u dv is equal to uv minus the integral of v du. And now, so the way integration by parts works is that if you have a problem, you have to choose a u and a dv. But it's not always obvious what parts of the function you should make your u and what parts you should make your dv. So I wanted to give you some example problems to give you some practice with these. Now, in general, you want your u to be something you can differentiate easily, and you want your v to be something you can integrate easily. And so let's take a look at this first problem, just to see if we can get some practice with choosing our u and our dv. So in my experience, I've found that whenever you just see an x like this, you should always just make that your u. So I'm going to do that, and the rest becomes the dv. So let's write everything out. We know our u is equal to x, all right? Which means du must be equal to dx by implicit differentiation. Similarly, we now are choosing our dv to equal e to the x dx. And this means v must be equal to, well, the derivative of e to the x is e to the x, so therefore the integral of e to the x must be e to the x. All right, and now let's just plug everything into the formula. So what we have is u dv, that's this x and the e to the x dx. We know that must be equal to uv, which is x times e to the x minus the integral. So now we have to minus the integral of v du. So v was e to the x, and then du, remember, is just dx. All right, but we know the integral of e to the x dx. We did it already here. The integral of e to the x dx, that's just e to the x. So this entire thing becomes e to the x. And so when we put everything together, this and this, we now have the answer is x e to the x minus e to the x. And then because we have an indefinite integral, we have to put a plus c. All right, and that's our answer. And if you want, you could pull out an e to the x to make it e to the x times x minus 1 if you want. All right, let's check out this next problem. This next problem is a classic integration by parts question. And you may look at this and say, wait a minute, there's only one function there. I thought you need multiplication of two functions. But this actually, you can write this as a multiplication of two functions. You can write this as the integral of 1 times the natural log of x dx. All right. And now we have a multiplication of two functions, but what should we make our u? Remember, u we want to be something that could be easily differentiable. And it turns out both of these functions are easily differentiable. Remember, the derivative of the natural log of x is 1 over x. So we could make either of these our u or dv, but I'm going to make the natural log of x equal to u. So this is going to be our u, and then therefore this 1 dx, that's the dv. All right, and so let's write everything out. So here we have u is equal to the natural log of x, and du must be equal to 1 over x dx. All right, and we now have the dv. We're choosing our dv. Let me make that more v shape. This is equal to 1 dx. All right. So when we integrate dv, we get v must be equal to x. Okay? And now let's just plug into our formula. So the integral of u dv must be equal to uv. So u is natural log of x times v, which is just x. So I'm going to write that over here just to make it look nicer. Now we have to subtract away the integral of v du, which is x times 1 over x dx. But now if we look here, the x's will cancel, and we're just left with the integral of 1 dx. And the integral of 1 dx is just x. So this entire thing just becomes x. So we can write our final answer as x times the natural log of x minus x, and then of course plus c. And that is the answer. Yeah. All right. So here's just some beginner problems, just getting you started. The hardest part about integration by parts is for sure choosing your u and your dv. And remember, if you're looking at a problem that you suspect you might need integration by parts, it doesn't hurt to just try a u one way and a dv one way. And then if things don't work out, if you get a function, a more complicated function, you can always try a different u or try a different dv, all right? In the next problem, I'm going to show you a classic test question. There probably hasn't been a Calculus 2 course taught that doesn't have this question on a quiz, all right? So that will be for the next video, and I will have an entire video dedicated to it.